Good morning, Caitlin. How's things?
Hey.
How did test go?
The quiz went fine.
Okay,
Nothing really too hard on it.
no surprises. That's what I want my students to say. Even if they don't do all the questions, they should at least say, I remember seeing something kind of sort of like that.
Yeah, I barely finished it.
Was that timed problem?
Huh? What was that? Yeah,
Wait, did you write a time? Yeah.
Almost.
Oh, but you made it just in
Barely.
time. Right, that's all it needs to be, right? 1 second to spare is just as good as 10 minutes.
Yeah, I took up the whole time too.
What was the slow down process? Was it just a number of questions, or was there a couple of questions that just took a lot of time?
It was like the ones where you had to graph one specific period of it, but it was like weird ratios. It was just weird.
Right.
Some of them.
You know, Desmos is really good at doing that.
Yeah, and that's what took up most of my time, was putting it into Desmos.
Getting it formatted and making it, because Desmos, nothing's perfect, but you know, sometimes the scales are weird. But Jason showed me how to make the scales better, so I've learned something. So I'm good. I love it when I learn things. I hope when I'm 99, well, I hope I live to I'm 99, but I hope when I'm 99, I'm still learning stuff. And I hope it's not my name. That's a joke. Ali, I just said a joke there and I get no reaction whatsoever from you. I said, I hope when I'm 99, I'll learn things, but I hope it's not my name.
That would be really
now she got the joke.
I was spaced out when you first said it. I'm sorry.
I can't take her anywhere. Right. Jason, do you have a really bad joke for us?
Yeah.
Oh, hold that
All
thought.
right.
Hold that, not yet. We've got a few more people coming in. So once
I
they're
have
all in,
one
or
bad
most of
enough.
them.
I'm pretty sure you don't want to hear it.
You have a joke as well, Aaron?
I
I love
do.
to hear bad joke. Right, we are going to have 2 jokes today. We are doubly blessed. Go. Hold that thought until here we go. Till the rest of the class gets in, and then we'll move from there. Okay. We really can't wait much longer. Just another minute. I get some I need to read. Someone's gave me okay. Jacob, I'll have a look at your issue later. Once I finish this class, I'll go in and see what's going on. Okay, good afternoon, everyone. We have 2 jokes today. Actually, I'm going to tell you one as well, because one of my Calc 4 students gave me a really bad joke. Jason, go for it.
My grandpa always said, when one door closes, another one opens. Great man, horrible cabinet maker.
Oh, I forgot. Who's next? I'm just going to buy that one really quick, because mine is worth, by the way.
Yeah.
What you got? Oh, Aaron, what you got?
It's a really bad joke. It's about vegetables. And it's
Go
pretty
for it.
corny. It's about vegetables and it's pretty corny.
Oh, God, I missed it the first time. Corn. Okay, here goes. This frog goes into a bank and he goes over to the teller and he's reading the name. And the name of the teller is Paddy Whack. And he looks at it and he says, that's a very unusual name, Paddy. The person says, yeah, it says that I'm Irish. That's my name, Paddy Whack. And so the teller says to the frog, what are you here for? He says, I want to borrow $20,000 to go on holiday. And the guy says, that's a lot of money to borrow just to go on holiday. Have you any collateral? And the frog goes to his pocket and brings out this tiny little ornament and says, there, that should be collateral. And the teller looks at it and doesn't know what it is. Says, I'll have to check with my manager. And he goes in and he hands it to the manager and says, there's a frog outside and he's gave us this as collateral. I mean, what is it? And the manager looks at it and he says, it's a knick-knack, paddywhack, give the frog alone. Now that's from Calc 4. Can you see the quality of students we're producing at this college now? Okay. I thought that was hilarious, right? Knick-knack, paddywhack, give the frog alone. Ali, are we the only two that get that?
I guess. I don't know.
Okay, here goes, guys. We're looking at trig functions, so I want to get them finished today, and then we're going to look at another function, a group of functions called inverse trig functions. So I guess the theme today is inverse functions and trig functions. So here are some functions. Let's look at a sine function. Quite a lot of this is review, but I just want to make sure that we're comfortable with all the things. If you get a sine function, or for that matter, a cosine function, then the three things that you're likely to be asked in whatever order they decide is the amplitude, the period, and they call it the horizontal shift. And as long as we remember how to do these guys, they're pretty straightforward, right? So really just for revision, what is the amplitude of this sine function?
3.
Great. If this was -3, wouldn't the amplitude still be 3? Remember, amplitude's positive. What would be the calculation to find the period? So you might know the period already, but what is the calculation for it?
2 pi divided by
Whatever that number is.
yeah.
And so you get pi. You nailed it. Great. Now, horizontal shift, isn't the horizontal shift this guy? And in this case, isn't it positive pi upon 6? And then very often, but not always, don't they have a question where they give you 4 pictures and you have to tell me which one that is, right? And I would do that in Desmos probably, right? Now, that works for sines. Doesn't that also work for cosines? So I won't do cosines. Now, there's another pair of functions. And there's an example of them, where you wouldn't be asked the amplitude because the amplitude doesn't make sense, right? Secants don't have a high and a low, don't they? They don't go up and down. There isn't a secant a big happy face that goes on forever and then a big sad face. Remember the happy face, sad face, happy face, sad face. So you won't be asked it because it doesn't make sense, but you could be asked the other two. And I've made this one a little bit harder. To find. So you could be asked the period, right, and the horizontal shift. If you have a function and it's written in this format, it's probably a good idea for you to rewrite it like that. Agreed? Because when it's written in this format, doesn't these two questions become easier to answer? Now, do you notice what you did is you pull out whatever that number is as a common factor, pull it out. That leaves you with x. Then you have some ugly fraction that, you know, basically if you take that guy and divide it by 4 is where that came from. Okay, now in this question, what is the period? What is the period of this
That
secant?
pi over 2.
Correct. And as a calculation then, 2 pi divided by 4, which is pi upon 2. Nailed it. Would you agree the horizontal shift in this question is pretty easy? So I'm going to change the question and make that positive. What's the horizontal shift now?
-pi over 4.
Okay. And we're comfortable about that back to front thing, where it kind of looks the wrong way, but it is the correct answer. Now, the last one in this set are tangents and cotangents. Stick a number there. When you do tangents and cotangents, the only two questions that really make sense are the period, and I finally figured out that I can call the horizontal shift HS. Now, the way this is written is probably not the best format. So just like we did here, take the 2 and go X. Right. What ugly fraction has to go here to make them equivalent? What goes here?
Pi over 10. I mean,
That's it. Yeah, no, you're right. Don't you take this and divide it by 2, and that is pi over 10. You were right. So now that I've got this set up, okay, I'm going to put this one down first because it's pretty easy. The period for a tangent and the period for a cotangent do not use the same formula as these guys do. It's similar, but not the same. What's the formula for the period of a tan or a cotangent function?
is it just pi over the number?
Yeah, just pi over the number. Can you see that be an easy thing to forget? Because, that's just the way these things work out. So if you're looking at a tangent function, it's pi divided by the coefficient of x. If you're looking for a sine or a secant, it's 2 pi divided by the coefficient of x. And then you have some questions where you then go and sketch it. So I'm going to go over to Desmos and we'll see what we can get here. If you want to do a sketch of something, sometimes it's a good idea just to maybe sketch one period of it, but very
What was
often
the amplitude again?
there is no amplitude for a tan function.
That's right.
Yeah. So if we do, what was the one I had? -3. Good grief, can't read my own writing. -3, the sine of 2 times x take away, type in little pi, and what was that, divided by 6. And I think if I get more brackets, I need both brackets. So bracket not there. It kind of knows where the brackets are. So if I hit enter, it'll put them in. It does. Right, can you see that function is now sketched for us, right? Now, if you wanted to restrict what it was drawn for, you could simply put in a little what I call curly brackets. You'll find them near the enter button. And you could say 0 less than or equal to x less than or equal to pi. So if I just wanted to see it in a small part of the world, you see it would look like that. Now, I believe that the period of this function was pi. So that's what the guy looks like. Cool. Now, if I wanted to see a little bit more, couldn't I change that to maybe, I don't know, 2 pi? If I really wanted to, I could even start at -pi divided by 6. There, if you see it that way, can you see the shift a little bit better? You see it's been kind of shifted to the left, and I bet you it's been shifted to the left by pi upon 6. Do you see that pi upon 6 guy? Exactly what you say. So you can adjust the window by essentially adding on this bit here, right? I find it easier if I don't see too many curves, right? So if I just say only draw it in this range, it's easier for me to see the patterns. Would you agree that it's pretty obvious? The height is 3, so that's the amplitude. Right. If I wanted to know what the period was, when I look at the distance from here to here, oops, wrong button. the distance from here to here, can you see it? And that would correspond to the period. Now, if you change this, I'll keep that one, write a new one, I think. If you do y equals and you go secant of 4x add pi, make that one go away now for a while. There we go. And I want the range in that one, well, at a period of pi upon 2. So why don't I just copy this with Control C, Control V, and maybe just do a 0 to pi. That's enough to see there. Can you see that happy face, sad face thing going on? You get the gist of the curve. And I'm not doing the tangent, but wouldn't the tangent look very similar? So if you got those questions where they give you 4 pictures, we could simply just use Desmos, draw a sketch of it, and then compare it to their pictures. And we can adjust it, make it bigger, roll the mouse pointer, I wouldn't do that way. Move it around a little bit so it just looks closer. Any questions about how you do the Desmos? And I don't know, have I ever shown you the little trick of the curly brackets? You've seen it? Okay, so it's not new. Let's go. Let's I'm going to come in for a second here. And I'm going to show you some of the other questions that you would get in that section on other graphs, I think it's called. Oh, there's a right off the bat. Here is a function. Can you, one of those pictures there is the right one. Can you imagine you put it in a Desmos and you found the right one? I can tell you right now, because it's a secant, doesn't it have to be 3, 4, or 5? Would you agree? How do I know it must be picture 3, 4, or 5, even though I haven't went near Desmos yet? The secant of 2x has to be 3, 4, or 5. How do I know that without drawing it in Desmos?
The little smiley face or frowny face things, like you said, just like
yeah. So happy, sad, happy, sad, happy, sad. Won't these guys here probably be tangents or cotangents? Because that's what they look like. Anyway, there's some more examples of, here is a function. Can you imagine doing it in Desmos and then, you know, picking, well, in this case, you just say it's that one. I'm not saying it is, but that's what you would do. Is it okay for me just to scroll by these and say the Desmos will do most of it for you? If you're interested in what windows to make, if you look at this one, see how it goes from -2 pi to 4 pi, wouldn't that be the window you choose in Desmos so it would look similar? Right. So if the window goes from -pi to 2 pi, maybe you should use that window or whatever. Nothing to see here. Here is a function, plug it in a Desmos. I could have a good guess at this question right now. There are 4 pictures here. Which one of those 4? And that's top left, top right, bottom left, bottom right. Which one of those 4 is 4 plus sine x? And I didn't need to go and do it in Desmos. Four plus sine x. Which one of those is it?
Wouldn't it have to be the bottom left?
I agree. You are correct. What were the clues?
Well, you know, it has to go at least 4, but it's positive 4, so it has to go up.
So it started at 4. And do you notice it starts at 4 and then it climbs to 5 and then it goes down, you know, to 3? Isn't that exactly what plus or minus 1 would do?
Yeah.
So we're basically using the amplitude, and there's another one similar to it. Same kind of thing, pick a function, sketch a function. Oh, I haven't done absolute value. Okay. Some of you may not have use Desmos with the absolute value function. So give me a second to find the darn thing. Where are you, Desmos? Here we go. Can you see Desmos right now, or will I have to go out and then? Oh, good, you can see it. Right. Let's suppose I wanted to do y equals the absolute value of sine x. So hit that little guy down there. And you see this fella here? That's your absolute value. And then you can just do sine x. Oh, doesn't it look like a bouncing ball on the road? You agree? Now I'm going to do that same function, but I'm going to change it as well. I'm going to do the sine of the absolute value of x. Oh, it didn't like it. Okay, I can make that happen because that is a valid function. I'll put a bracket in it. There. Okay, that one needed the bracket. Let's hide this one. The sine of the absolute value of x and the other one. You see they are different, right? Absolute values, depending on where you do them, make big differences. And where are we with questions? Okay, so that would be 15. Nothing to see here. There's some more amplitude and period questions, which I think we probably flogged to death by now. Here's some with some horizontal shifts in it. I mean, if I was doing that one, wouldn't the amplitude be 5? The period would be 2 pi, and the horizontal shift would be negative pi upon 2. I mean, hopefully, in this one, wouldn't you have to pull out the 3 as a common factor and get a little bit more work to do? And that's us. Is there any questions about those particular questions, those particular guys? Are we good now? So if I gave you a function and said, tell me its amplitude, its phase shift, or as they call it, horizontal shift, its period, do a sketch, tell me which one it is. You feel good? I feel good then. We can move on. So we're a new section. And I'm going to change tack for a few seconds, because I want to tell you right now, in case I forget later. You all know, don't you, that a week today is your midterm. That's a big chunk of time, right? Big chunk of points. And it's going to be starting at starting at 1 o'clock. All right, it's going to last over 2 hours. What you also need to know is that a lot of these questions, not all of them, are going to be in a PDF that you're going to be writing the answers to. And some of these questions are going to have to be in WebAssign. So I want you to think of your midterm as having a part 1 and a part 2, right? The part 2 will be in WebAssign. The reason why that is here, aren't there going to be questions where draw the sketch of this and draw the sketch of that, and WebAssign and Desmos are much easier because then you just pick a picture. The vast majority of your questions are going to involve you showing me your working. And that means you're going to have to upload your working into Canvas. And the way you're going to do that is you're going to have your cell phone, and there's a software called Microsoft Lens, which I'll try and remember to do I will do it sometime this week and take you through it. Essentially, you take a picture of your working, you turn it into a PDF, and then you upload it into Canvas. And that's how I get to see your work. And the last thing about that midterm is that you need to be present and visible. So to prevent cheating, to be fair, everybody here has to have their video camera on. So you need to get one if you don't have one. You can use your phone as a video camera. You know, you can turn that on and prop it up somewhere so I can see you. It's Well, it's for security, and to be fair, right? See, I trust Jacob, so I know Jacob wouldn't ever think of cheating. But Jason's one of those unscrupulous guys. I can tell by his jokes, he's very unscrupulous. And I'm frightened that he's got a twin brother who's actually going to be helping him, or his big sister. And if I can't see him, I won't be able to tell if that's the case or not. Right? So that's security. Right. So I'm not going to start making judgment calls and saying, it's okay, Jacob, you don't need your camera on, I trust you. But Jason, you better not switch your camera off because I think you're cheating. Right? I'm picking those two people because I know that none of you two would cheat, right? But I'm just saying that. So that's the reason. That's it. Any questions about that before we start the next section?
Yeah, I actually have a quick question.
Mm-hmm.
So I take my notes and I write all my work down on an iPad. Would it
Yep.
be acceptable for me to do that?
You mean do your working that I need to see?
Yeah.
Can you turn that into a PDF? And
Yeah,
send
I
it to me?
can.
Then
Mhm.
you are good to go. Yes, you
Okay.
can do that.
Because I didn't want to make it seem like I would be cheating off my iPad, but I take all my notes and stuff on here.
Yeah. The
Okay.
thing is that you are allowed to use notes that you've got anyway. So if you've got notes like, off the top of my head, a unit circle, for instance, wouldn't that be a good thing to have a note of? Because you use it a lot in certain sections. And you're allowed. So you can send it, you can use your iPad to also have your notes on it, although it might be a little bit
Thank you.
awkward going out and in. Do you have two computers? How do you do the questions? Do you have a computer for that and your iPad
Yeah,
for the
so
other?
I just have it right here.
Okay,
Yeah, and then I just look off my computer and write everything down.
perfect. So you'll have no problems then, right? You'll be cool. Any other questions about the midterm? Whoops.
It's not about the midterm, but why is there assignments on WebAssign out until March?
I did a typo. I think I meant 2 and I probably put in 3.
Yeah, I saw one on March. It was very confusing.
I will have a look at that. I'll take a little note right now. It shouldn't be there. Is it one that's going to happen in the future, or is it something that's old with a funny date on it? What's the topic?
I can check real quick. I just know I saw it. It said March was the due date, so I was like,
No, that sounds just like a typo. I typed in the wrong number.
Yeah, it was like I believe 5.5 and 5.6.
yeah, 5.5 and 5.6 inverse trig in harmonic.
Oh, okay, right. I will make sure that I fix the dates
Wednesday,
to be
March 9th.
Yeah, I'm pretty sure that's the wrong date. That will be this coming Sunday, like all the others.
Yeah, I was like, that's a little far out.
Yeah. Okay. Right. Let's get started on our next section then, if that is all the questions.
Oh, I gotta mute my-
So, section 5.5, we're going to look at what's called the inverse trig functions. And I'm going to show you, right. Let's look at some properties of the inverse sine function. The inverse sine of 0 is the same thing as what angle has a sine equal to 0. So we're just trying to find an English way of interpreting what that is. So I'm looking for an angle who has a sine that is equal to 0. What angles have a sine that are 0? What angle has a sine that's equal to 0?
180 and
Let's
0.
see. Yeah, there are 2, isn't there? So if I do inverse sine of 0, the calculator only picks the 0. Now, the other extremes are these two, which is probably where I should have started when I was talking about drawing the sketches. The sketches were fine. It was domain and ranges I got back to front. So what angle has a sine of -1? Well, if you go in here and you do inverse sine of -1, you're going to see a rather weird answer. It's going to be negative, that fella. And that guy is negative pi over 2. And what angle has a sine of 1? That one you should be able to do. Isn't that 90 degrees? That fella. Now, if I start my little picture again, without letting my calculator distract the heck out of me, the sine of 0 is 0. Right? There I did it again. The inverse sine of 0 is 0. The inverse sine of this guy is negative pi upon 2, which is here. And the inverse sine of 1 is positive pi upon 2, which is up here. And can you remember the curve thing that went like that? There we go. I'm now much happier with my inverse sine. In fact, pretend that other stuff wasn't there. You have a domain and a range. Now, isn't the domain from here to here? Right. So in this case, the domain is -1 to 1. Can you see how my first time round I got those two mixed up? Now, what is the range? What is the range of this function?
Negative pi over 2 to pi over 2
There,
with brackets.
we're good. I'm so much happier I did it. And putting notes out, it kind of changed my mind. The way I set this one up is probably better than on the calculator, because unfortunately on the calculator, I just didn't pay attention. And I had the right numbers, but I switched them around. So still on the inverse sine function. What do you think you get if you take the inverse sine of sine x?
X.
You do. Can you remember there was a property that said if you find the inverse of an original function, don't you get back to x? Can you remember that in 141? That's essentially what that's doing. If you square something and then you take the square root, don't you end up back with the number you started with? It's kind of that property. Now, then it doesn't, or it shouldn't surprise you that isn't that also true? What do you think would happen if you did that?
The same thing.
You would expect, agreed? And up here, you notice the way I phrased it, you would expect. Because sometimes it is and sometimes it's not. What do you think you would get with that then? Same thing, right? Well, let's show you a little idiosyncrasies. Let's pick ones that I can do pretty easily. Let's do the inverse cosine of the cosine of 1, which is a pretty ugly number, right? Works perfectly fine, right? Exactly what you think, right? Start with a 1, finish with 1. What about the inverse cosine of the cosine of pi? And by the way, that's pi. What about the inverse cosine of the cosine of 5 pi? Would you expect the answer 5 pi? Guess what? You only get pi. And it's because of domain and range. Can't a sign never get bigger than 1 or less than -1? And so when you are doing these relationships, they are true as long as x is in the domain. Right, so as long as you're picking an x that's in the domain of the inverse sine or the sine function, or the inverse cosine or the cosine function, you should be good. Are we cool with that one? Do you want to see a version from scratch of the inverse cosine, or are you comfortable with the messed up one I've got? Because I think actually I fixed the mixed up one.
So I have a quick question for
Yes.
inverse of sine.
Mhm.
It would be -1 to 1.
The domain would be -1 to 1, yes.
Gotcha. Okay.
And for the inverse cosine, it's -1 to 1. I guess I should put in the 10. Is it okay to skip the cosine, or do you want to see this done with a cosine, an inverse cosine? I don't want to skip something if you feel you want to see it. Do you want to see a sketch of the inverse cosine? Don't care? Okay. We'll assume it's not too big a deal then. The third and final one that I'm going to be doing then, it's not used often, but it does appear sometimes, and that is the inverse tan function. And obviously it has a sketch, and it has a domain, and it's also got a range. And if we go here, should be set up. I'll go in here, and I'll clear this one out, and I'm going to put in the inverse tan of x. The domain of the inverse tan function is all real numbers. For instance, isn't it possible to get a tangent equal to 50 to be 5 million, right? Any number minus 5 million. So its window, I can't really do minus infinity to plus infinity. So how about -2 pi to +2 pi, just to get a feel for what it would look like. And then do a zoom 0 on it. And the function looks like this. So here's x. And I'm going to put a little dotted line here. If you look really carefully, can you see a horizontal asymptote beginning to form at the top? And you can see another horizontal asymptote forming in the bottom. So 1, 2, 3, 4, 1, 2, 3, 4. So this shape essentially looks like this. And that's what the inverse tan function looks like. Now it does have a range. It never gets higher than this number, and it never gets lower than that number. What are those values? What do you think that horizontal asymptote's number is? Let's put it a different way. What angle do you have a real hard time getting the value of a tan function?
90.
And the tangent of 90 degrees is 1/0, isn't it? And that's infinite. If you're doing a tan function, wouldn't it look like that? See it? So 90 degrees is pi upon 2 and negative pi upon 2. So the range doesn't use the two outside numbers, right? It never gets to pi upon 2. Doesn't it just get closer and closer to being pi upon 2? Are we comfortable with the inverse tan function and what it looks like? And of course, don't you have your calculator handy? You can always look at it. Now, do I have my unit circle handy? I hope I do. You got it, Andy? Okay, I'm going to have to rely on your unit circles. So hopefully somebody's got one that isn't miles away. Ah, might be here. Okay, this one's not the one I was looking for, but it'll work. Not the one I was wanting. No. Okay. Here is my unit circle, and we're going to use it to answer, find the exact value of. So I want to find the exact value of that. Now, when you look at your unit circle, am I looking for an X or a Y coordinate?
Y.
Y coordinate. So I'm looking for a Y coordinate that's equal to √2/2. Agreed? Now, when I do that, I'm going to find two answers, but only one of them is the one I want. Would you agree that the missing angle could be pi/4, or it could be the guy over here, 3/4 pi. And so which one do you choose? Well, don't you choose the one that is in the range of the inverse sine function? So if I can find my inverse sine function guy, isn't it in the range -pi/2 to +pi/2? So which one does this guy get you? That guy or that one? Which one is in the range?
pi/4.
And that's how you decide. Because if you use your unit circle, aren't you probably going to get two possible answers, but only one of them is the one that you choose? So I should maybe put a little summary somewhere. For the inverse sine function, our guy, our range, is -pi/2 to pi/2. For the inverse cosine function, our range, and then finally, the inverse tan function, our range. Okay. What is the range of the inverse cosine? Because it's not the same as this one.
0 to pi.
Okay. And the inverse tan, I've got it here. Technically, isn't the range actually a curved bracket? So when you are looking at your unit circle and you're trying to decide which one of the two to pick, always pick the one that's in this range. How about then the cosine, oh sorry, the inverse cosine of -√3/2? Now, if you're looking for an angle that's got this, am I looking for an X coordinate equal to this or a Y coordinate when it's a cosine, inverse cosine?
X.
So I'm looking for an X coordinate that's -√3/2. And when I look for an X coordinate that is -√3/2, the guys I get are 5, 6 pi, how's that? And the other one is 7, 6 pi. Now, which one of those is in the range? And so that's the answer. So can you imagine in each situation, you're going to have two choices, but only one is the right answer. It has to have one answer because it's a function. And the rules are for any given value, you can only have one answer. Try an inverse tan. I want to know the exact value for the inverse tan of root 3. Okay, well, that's basically going to be the y over the x coordinate equals root 3, which isn't actually that much help. But somewhere in this list, isn't there an angle whose y coordinate divided by its x coordinate ends up being root 3? Agreed? So where is the y coordinate divided by the x coordinate positive root 3? I can see one of them already. Which angle?
Could it be pi over 6?
3.
Well, I hear pi over 3 and I heard pi over 6. So if you do the y coordinate divided by the x coordinate, that one doesn't work. But if you do the y coordinate divided by the x one, this one does work. So that's one possible answer. Would you agree there's another one somewhere hiding? Where's the other one?
4 pi over 3.
So let's check this one. If you take that y coordinate and divide it by this one, there is your other one. Where do we go looking for an inverse tan? You can only use numbers in this range. So which one of these two actually works for this story?
The first one.
The first one. Have you noticed that after a while, don't you kind of get used to it? You know, you're going to have two choices, and that's essentially how you do those kinds of questions. Do we have any problems about these questions? Find the exact value of inverse sine, cosine, or tangent. Do you want to see more of those, or do you feel good? Okay, okay, like that. Oh, I just noticed one before I moved on. Trick question. What's the inverse sine of 2? And it is a trick question.
Well, I have a feeling that this is a trick question.
No. Where did you
Doesn't
get
work.
that from?
Yeah.
Okay, yes,
Would this be none?
correct. It's impossible.
Error.
Error. Oh, well, I guess if you go in your calculator just says error because it's true. It's not possible. And what do they go? Well, to keep WebAssign happy, we don't say error or even impossible. According to WebAssign,
Undefined.
you write down in capitals undefined. Has anybody wrote undefined in little letters and found out that you had to do it in capitals, or was it at least generous that way? Not
I haven't
everybody's.
tried. I don't know.
Yeah, you get 5 guesses, right? Have a shot at one, just curious. I can type things in, but it won't tell me if I'm right or not because I don't get the same version that you do. No, they just got an awful lot of these guys. Now, the next bunch of questions is dead easy because all you're going to do, okay, what's she doing? You little blighter. Come here. Come here. This little girl, this is Chloe, has decided that the cables underneath my table are edible. And yes, you. And she'll, yeah, okay. She's sucking up to me now because she knows she's in trouble. And she pulled a cable 2 seconds ago. And I was kind of surprised when I looked under that I saw her with the cable in her mouth trying to take it away somewhere to chew. She's not too bright. Okay, are you happy now? Okay, I'll let you down. Now, on your calculator, you're going to be asked to find inverse sines, cosines, and tangents of weird numbers that are not in your unit circle. And all you're going to do is to write down the answer correct to 5 decimal places. So here it goes. If somebody said to me, find the inverse sign of, pick a number that exists, 0.12, that's the answer if you round it off. If they ask me for negative 2/3, there's your answer. You agree this is going to be dead easy. You just plug into your calculator. Now, what happens if they ask you to find the inverse tangent of a huge number? Well, the answer is 1.57 roughly, which by the way is pi upon 2, as you'd expect. And they might, because they feel like it, ask you to get that one. And I know at least a couple of you have done this. What's going to happen when I hit enter?
Error.
Right? It even tells you it's not in the domain, which is better than nothing. And so that is going to be called undefined. Can I call those ones done? Right? Now, if you combine them, you might get a question that does this. The inverse, oops, hit the wrong clear there. The inverse sign of the sine of a half. And the answer is a half. You might get the inverse sine of the cosine of pi divided by 4. And that's your answer. And can you imagine that there might be some combinations that don't exist? Like an inverse tan of a cosine of 4 or something weird.
So these are just simply plug it in your calculator and get the answer.
Yep.
Okay.
Right. So there are a whole bunch of questions where the answer is going to be 5 decimal places. And I have enough time for this. It's only 3 minutes. I can do this. Do not do this on a calculator. But the answer is not difficult. What is the answer to that as an exact value?
Pi over 7?
Aren't we using the fact that they're inverses and they essentially cancel each other out? There is a couple of other questions that I don't have time for, but I'll see if I can, well, I will, I'll fix them tomorrow. And that will be the end of that section. So make sure you've got your last name down.